For example, how to collect payments on my course website using Ethereum. So I've heard that there's a library called Ethers, ethers.js, which can be used for this kind of a purpose. So let's figure out using ChatGPT how I can use this library. So the first question I asked ChatGPT is just simply, how can I use the Ethers library to collect payments with ETH? And it tells me some steps. So the first step is to create a wallet where I'm simply requiring the Ethers library and declaring a random new wallet. I think Ethers library also has a function to use an existing wallet. So I can, of course, look that up later. But basically, I get a wallet object. The next thing I have to do, step 2, is deploying a smart contract. And so it shows me a little bit of the code for deploying a smart contract. So what's happening here is it's creating this ABI constant, a bytecode constant, and declaring a new contract using the Ethers library with the ABI, the contract address in the wallet, and then it's deploying the contract bytecode, and the promise is returning a deployed contract, and then it's logging the address of the deployed contract. So, okay, I'm not sure how it got the contract address here because it never declared anything, but it got the ABI and the wallet in this piece of code. So, and then it seems like the contract address is coming back. So we'll find out how it got to that. And then step 3, it's trying to receive payments from the user. So, okay, so there's basically the contract deploying, and then there's the contract depositing. So the deposit function here is basically returning a balance, and we are converting that to a string and logging it. All right. So now my next question is, what is exactly this contract look like? I'm assuming that's the bytecode. I don't know where that came from, right? So let's see. Okay, Solidity is the language which is used to program Ethereum contracts. And so here, the ChatGPT has given me an example of a contract with a deposit function. So, right, so above we basically had a contract functions deposit, and we had a contract.deploy. So I think deploy just comes as part of the default contract itself. And the deposit here is as you can see, it's separated by dot function, so it's part of our actual contract, right? Because the deploying would happen where we are deploying the contract to, let's say, the Ethereum blockchain, and the depositing would be a function of what our contract is able to do. So, okay, let's take a look at the contract real quick. So Pragma Solidity 0.8.0, I guess that's just specifying the Solidity version to use. And then normally we write things like class something. Instead, we're going to write contract, and receive payment here is the name. And then we can see that there's a type address payable, which is public, and there's a recipient there. And we are going to put the value of the sender from the message in the constructor as the recipient. And then we are going to have a deposit function, which is a payable function, and it's public. Payable is a Solidity keyword. And we're going to require that the message value has to be more than 0. Otherwise, we're just going to throw an error saying cannot deposit 0 ETH. And if the message value is more than 0, we are going to transfer that to the recipient. recipient's going to transfer that. Or, sorry, we're going to transfer that to the recipient. Okay, so that's our contract that it created. And then it's just explaining what I explained about that code. And then it's telling us that there will be a gas cost when we are deploying this contract to the Ethereum blockchain that we will need to be ready to pay. And so we need to budget accordingly. So I ask it the next question, how much is that gas cost going to cost me? And it tells me that it depends on various factors like the network conditions and the complexity of the transaction. And in general, it's like from few cents to a few dollars for the contract for a simple transaction like the one I have above. And it can be more depending on the network congestion and demand for the gas. All right. And it's a good idea to monitor the gas prices and adjust your fee estimates accordingly. Okay. So nothing very specific there, but from a few cents to a few dollars is what I gather. And it also tells me that I can prioritize my transaction by setting a higher gas price. And that would allow me to pay a higher price for getting priority on my transaction. But it can also result in an overall higher cost if I do that. So you can do this by specifying a higher gas price in your Ethereum wallets when sending a transaction to the smart contract. All right, so then I had the question of what is the payable in the contract, which I explained to you. It's basically a keyword in Solidity. And without the payable keyword, the function cannot receive ETH as an input. And any attempt to send ETH as a function will return an error. So we had the deposit function marked as payable. And it also helps us know which functions can accept ETH and prevent unintended errors or vulnerabilities. All right, and then my next question was, how do I actually integrate that contract with the Ethers library? And the idea there basically is that we write the contract in Solidity, we compile it, and here it tells us that we can use a compiler. There are several available, and an example it gives us is Remix. And so when we compile it, we are basically going to get that bytecode and that ABI that we used as constants at the beginning of our first script, where we deployed the smart contract. So what we're basically going to do is we're going to write the contract, we are going to compile the contract, and that will give us this ABI and bytecode. We are then going to create a new contract using that ABI and bytecode, and we're using that ABI and our wallet, and we're going to deploy that bytecode using that contract object, and we will get back our deployed contract. Now, then we can interact with the contract using the contract.functions.deposit function and keep depositing that way. Okay. And that's just an example to give us an idea of how to use the Ethers library to interact with the Solidity contract. And then it just talks about the gas prices again, and to make sure we monitor them. And then where does the contract address come from? So the contract address comes from when we deploy that bytecode and we get that deployed contract, it gives us another contract back, which is basically the deployed version of it. And that's where we can get the deployed contract address. So I guess the first time around, we just throw in some address. And then in the example, the contract address is stored in the address property of the deployed contract. And if you already have a deployed contract and you want to get a contract object based off of that, that's when you can use the new ethers.contract with the contract address that you already have to get a contract object. Okay, so that makes sense. I wonder if there's... Yeah, so I'd probably just pass in null or something, or check the documentation for what to pass in for the contract address in the first case, where you haven't yet deployed. And then once you have, then if you wanted to get a contract object from that, you can always just throw in the address. All right. My next question was, what would the UI look like for asking users to send payments? And it basically suggested that there would be a recipient address, a payment amount, a gas price, and a gas limit. And the recipient address would be the smart contract address, where they want to send the payment. So this was kind of awkward to me because I would be supplying the recipient address since I created and deployed the contract, and there would be a payment amount associated with it. So how do I actually get the users to do it? I kind of had that asked differently then. Should I ask the user for his wallet address? And it said, no, I shouldn't. I should simply give the user the address to the smart contract. So this hexadecimal here. And they can then, and I can put that address in a QR code if I want to, and they can scan that QR code and use their wallet to make a payment to that particular address of the contract. So that's kind of the idea with getting users to pay is we simply will publish our address, our QR code, and they will send payment to our address. And so we would then need to check that they have sent us that payment, and our contract can then basically tell the Ethers library to further process using JavaScript our actual order. All right, and my next question was, if I'm selling online courses, can I let the user click buy and pay me instead of having to go to his own wallet? And the answer was yes, I can do that. There are popular payment gateways to help me do that, such as Coinbase Commerce, OpenSea, and Uniswap, in which case I will also have to pay their payment gateway fees, though. And so that can be a little bit more simplified or streamlined process where the user will have given their wallet address to a trusted third party like Coinbase or OpenSea or Uniswap, and they will take money from that wallet and give it to me after validating the payment. So, and then I wanted to know, what information does the payment gateway collect from the user? And the answer was basically the same things as before in terms of payment amount, gas price, and gas limit. The only thing that changed is instead of the contract address, the payment gateway will collect the actual wallet address from the user. Another thing to note in this text was that Ethereum transactions are measured in GUI, and each GUI is 10 to the minus 9 ETH. So that's what the Ethereum transactions are measured in. So it's basically just a smaller unit of ETH. And that's about it for the payment gateways. So hopefully in this tutorial, we didn't go and implement fully the Ethers library to collect a payment, but You should have, in this tutorial, learned the overall architecture of how you will put together your smart contract, your Ethers library, and your Solidity contract, and your deposit and deploying and depositing.